All right, now we're going to look at vectors, but we're going to do it algebraically rather than just geometrically. And the first thing I want to point out is how we use notation for a vector. And you may see it where we look at this V right here, that we are not using parentheses. We are actually using these kind of arrows on the outside that look like parentheses, but a little bit different, okay? And you also notice that it kind of looks like a coordinate point. And there is a relationship to the coordinate point in the sense that we say, well, A is the horizontal component of the vector and B is our vertical component of the vector. And so we look at it over here where V and A over B, we can see that. And notice that where we put the A, then B is in relationship to that coordinate point. And what that is saying is that we are starting and going to that point AB. And we're going to be doing that from the origin here at 0. So if it starts at the origin, we have a specific name for that vector. That vector is considered a position vector. And a position vector always is starting at the origin, like here. And remember, the origin is at 0, 0. Now, not all vectors, as we work with them, will be starting from the origin. But it is always important for us to go back to a position vector because it's going to be making our calculations. So what do we do in order to find a position vector? This is going to actually be fairly easy and it may actually make sense. You'll see a statement right here. But I'm going to do this problem down below to make it make a little bit more sense before we get there. It says sketch the given vector P1, P2. So the vector that starts at P1 and goes through P2. If P1 is at -1, 2, so -1, 2, and is going to go through P2, which is at 4, 6. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And this is going to be at 4, 6. And now what we're going to do is we're going to we start at -1, 2, and we go to 4, 6. Now the question is, how do we sketch the position vector? Well, we can do this a number of ways, but we're going to focus in on one specific way, and that is the idea of building out a triangle that is right and determining the distances. So what we would say is we're going to take our x's and subtract them. So this distance is 4 minus -1, which we know 4 minus -1 is the same thing as 4 plus 1, which is 5. And then we also know that in order to get from this location up, we would just simply say, well, let's find the difference of 6 and 2, which is 4. And notice this, we have these statements x2 minus x1 and y2 minus y1. Now the position vector is going to be based off of the idea that this side of the horizontal distance for this triangle is 5 and the vertical is 4. And so I'm going to go ahead and erase this piece that's in blue, okay? And what we'll end up doing now is the position vector will be going to the point 5, 4. So let's go to the point 5, 4, which is 1, 2, 3, 4, 5, and then 1, 2, 3, 4. So this is at 5, 4. So essentially this is your A. This is your B as a coordinate point. And what we are going to do is we're going to say that we are drawing from the origin out to 5, 4. And we'd say that V in this case is equal to 5, 4 horizontal of 5 and a vertical of 4. Now you should notice that if we've done this correct, that from 1 to -1, 2 to 4, 6 is congruent in length to 0, 0 to 5, 4 because they are representing the same vector, but that vector is now a position vector, meaning that we've moved it to begin from the origin. So we can only look or need to make calculations based off of the horizontal and the vertical components of that vector.